My coffee, I drink espresso like 99% of the time. So yeah, I'm not one of the cool kids who drinks, how do you call it, matcha latte or flat whites. No.
I am very excited today to be joined by Kubeflow's biggest fan, or at least that is what
I'm never going to live that down now.
Dude, I love it. And so maybe one person other than myself on the internet calls you that, but I don't care. I'm going to keep calling you it because I think you've probably been reached out by the Kubeflow community since that conversation we had, huh?
Yeah, we hang out with the Kubeflow community quite a bit.
There we go. So for those who do not know, Ryan came on the podcast. He was an excellent guest. We talked a lot about doing Kubernetes and machine learning together, specifically Kubeflow and how it works. And because this conversation that we just had with Rafa centered a lot around machine learning and Kubernetes, I thought, who should I have as the perfect co-host? I'm going to hit up Ryan and see if he's available. And the stars aligned. You were available. So we got to have this really cool conversation with Rafa. What are some of your takeaways, man?
I love talking to him. It was awesome. I think what I was blown away with was his history, just how he came to be to where he's doing it. To me, it seems like he was on the forefront of so many things that we just now take for granted, whether it be like just going to, what is it called? IoT before there was IoT? Is what he said.
Before there was the cloud. Yeah.
Before there was the cloud. Like, he was doing, it was really cool just to see kind of that. Whereas like someone like me who's kind of like stumbled into this field, I feel like to some degree, that took the scenic route. He's been kind of at the forefront. His insight was great too on just so many different aspects of just the machine learning lifecycle as it applies to Kubernetes. And his answer was really funny when I asked him the question about who's Kubernetes, or who's it right for. It was like, I don't know if he probably didn't listen to my conversation, but it's like verbatim what I said. So I was like, I felt really validated at that point. I'm like, yeah, someone else has my opinion, but yeah.
Kindred spirits, man. Yeah, right. You guys, exactly. Yeah, I really enjoyed at the end of it when we were kind of talking about must-haves these days. When you're looking at a machine learning platform, there's the nice to haves and there's the must-haves. And he broke down what he feels are must-haves. I think the surprise there for me was the explainability piece. And then I really liked how he talked about this. He gave it up and he said, look, we talk a lot about data lineage, but we don't talk about model lineage. And you can tell a lot about how a model performs if you can see everyone that has touched that model and everything that they've done with that. Maybe that was just because he wanted to give a nice little plug to MLflow. Maybe he just really is into that. Who knows? I get the feeling that it is the later. So it was, for me, one of my favorite pieces. I think we should just get right into this. Everyone who is listening, if you have not seen yet, we're doing meetups all over the world. Ryan's in SLC, the Salt Lake City, and we're doing MLOps community meetups there. We're doing them in Washington. We're doing them in Berlin. We've got them in India. There's even one in Australia. So wherever you are in the world, there's probably some MLOps community in real life event happening near you. I highly encourage you to get out there, hang out with some people. It's so invigorating to A, see people again, and then B, learn from all of these learn from your peers. Like we've got such cool talks that are going on. And if you're on YouTube, you might want to subscribe to our other channel that just puts out all of the in real life recordings. So we've got all of the talks that are happening at all of these in real life meetups. We started a whole new channel for that. Go jump on it, subscribe, do everything that you do with YouTube. And for now, we're going to just jump right into it with Rafa. Where do we even start with you, Rafa, man? You've been in the game for a long time. I don't even know where to get started. Why don't we start at the beginning? Give us a breakdown. What was your first job and how did you start touching data?
First of all, really happy to be here. Quite excited. I follow MLOps community. Yeah, definitely honored to be here. I think even before I started working, when I was a child, I was a huge video game geek. I got an Atari when I was 6, so I had a bunch of consoles, and for a while I had this idea that I wanted to work in game development. And at some point it just morphed into computer science. And so I started as a software engineer. really long ago when there was no Kubernetes and no Docker. But I started right from the beginning in a really one of the most data intensive industries back then, but also I still is today, which is the stock market. So I used to work as a software engineer in the Brazilian stock exchange. I come from Brazil, by the way. Worked in financial companies for a while, moved a bit to a different industry. I worked in telematics in an Israeli company. I lived for a while in Tel Aviv, by the way, amazing as well. Fond memories of those times. So it was actually asset tracking / car tracking company. So I like to joke and say it was IoT before there was IoT. So all these cars and trucks pushing all this data, not to the cloud because there was no cloud back then. We're talking about 2010. But basically we had a bunch of these TCP sockets running in a data center, and these cars talking to the sockets to publish this data. So we started, I think that was my first experience with data from a more analytics point of view, right? Because back then I remember we had use cases, for example, we needed in real time to detect if, for example, a truck driver from FedEx was leaving the area where he was supposed to be with geofencing, for instance. Other more analytical use cases, for example, I want to look at the fuel consumption for the last 6 months. Who is the driver who gets late the most? Who is the driver who is early the most? And this kind of thing.
And this was in 2010?
2010, yeah.
And you were doing real-time stuff in 2010 at this IoT with no cloud. And how did that even look back in those days?
It didn't look pretty, I gotta say. For me, it was also a huge paradigm shift. When I started as a software engineer, first of all, I worked mostly with batch systems and mostly with proprietary stack. So Microsoft was huge on C# and SQL Server back then. And this was, I think, my first experience with open source. So we were running Linux all the way. We were running C to process the streaming data in a really efficient manner. So it was all really new for me. So at the same time, it was quite exciting. But from the infrastructure perspective, I think it was one of the biggest challenges, right? So it was basically bare metal running a data center. And I think it was also a challenge to know first to scale and to know when to scale. You didn't have the elasticity, right? So it was a bit of a more static kind of a planning.
And would you say that is one of the biggest differences these days, and like something that you're the most thankful for, that elasticity that you can have now, just at the touch of a button, you can scale up or scale down?
Absolutely. I believe if I had to think about the top 3 biggest selling points of the cloud, for me, this would be number 1, which is quite interesting as well. That connects a bit to my personal experience with Kubernetes. I won't lie to you, the learning curve is a bit steep. I think in the beginning, it was a bit overwhelming because there were so many things to learn. The terminology was also kind of a challenge. I remember I used to think, what are these pods and what are these service accounts and all that stuff. But when I finally grasped that, the way I looked into it was, okay, so now I can control, it's almost like I can control an entire data center with code. And I can simply say, okay, instead of going there and placing a virtual machine in a rack, I can just spin up a pod or something that I found even more amazing, to just create a horizontal pods autoscaler and just leave it run. I was flabbergasted when I learned about all these things. So it was kind of a watershed moment as well, because from one side I was amazed, but also not concerned, but also I also felt challenged, but also I felt, okay, so I'm never going to have to deal with bare metal again. So that's a good thing.
What you're saying is pretty awesome. It's reminding me of all of the learning curve, the same thing I had to go through, right, of Kubernetes. What would you say was the single hardest thing to grasp when you were starting out with that?
I think I remember when I was in college, the networking classes, they were not my strongest skill, I gotta say. When I transposed this to Kubernetes, it was almost like it was haunting me again. So I would say probably, I don't know, if you ask me this question 1 week from now, I don't know if I'm gonna say the same thing. I can't remember the type of feelings I had when I was having to deal with that again. It was almost like I was going back in time and say, okay, this network stuff again. At the same time, there was a bright side, definitely. So I said, I'm gonna actually have to learn this. Not only because of Kubernetes, because also if you're running stuff on the cloud, you need to know that for the most basic security kind of requirements that you need to implement. That's essential. So yeah, I thought to myself, okay, let's kill two birds with one stone and let's learn this thing.
It's fun. That's exactly
what
what
about you
today. Networking, 100%. That's the hardest part, right? Like, especially, I was not a software engineer before I came into this. I'm like that traditional engineer building literal things, and then have to slowly move my time over here. And networking to this day still just haunts me. I feel it's something that no matter how many times I've done it, it's still, that's the crux. And there's a lot of that obviously going on in a Kubernetes platform. So that'd be the biggest thing for me. It's always been, it was nice to hear that was the same thing for you. So that's
the amount of times I've heard people talk about headaches with ingress. But so then let's jump into doing machine learning on Kubernetes and how you got into that, Rafa, and what you're looking at when you start to see, okay, Kubernetes has all of this potential. I'm all in on the cloud. I'm all in on Kubernetes. And now I'm going to not only do my analytics on there, I'm going to try and do more and more machine learning workloads. What are some things that came up and still to this day come up?
I have this ethos of trying things and breaking stuff. So it was almost like Kubernetes was untamed land, but at the same time, sometimes people, and myself included, are just naive. Okay, I'm gonna spin up these deployments and I'm gonna package my model as a container. Everything is gonna work. And then you start to learn about things like secrets management. How do we scale these to enterprise level as well? Because one thing is, you are working in a small team of 5 people and you spin up a cluster on AKS or EKS, for instance. Most likely it's going to be fine. But when you're talking about a machine learning center of excellence, I was talking to Ryan before we started. One of the places I worked, they had this interesting concept of a center of excellence specialized in Kubernetes. One of the reasons, because they were big on machine learning and Kubernetes. So in this case, you had this team who were like the gatekeepers of Kubernetes, but they were also like internal consultancy kind of team. So they provided the blueprint, all the CI/CD pipelines, all the Helm charts so that you could do your own thing. And it was 100% automated deployment. So zero manual intervention, which is also something that you don't think right in the beginning. And it's even healthy sometimes not to consider that, because sometimes you just want to run an MVP. And I think my biggest takeaway is you might be tempted to start things as an MVP in Kubernetes and to keep things like that. And then you just learn that it's not enough when it breaks. And some things you're able to predict. Some of the things are just common sense. I can just give a quick example. In terms of workload estimation, if you do a back of the envelope calculation, you can say, okay, I need to have at least 3 nodes to have high availability, each of them with 16 gigs of memory and so on. But things start to get more and more complex. And you need to scale at some point, and then, the challenges are different in that case.
So I want to follow up with that a little bit.
Yeah.
There's a lot of pain points, and we can I'd like to get into deep depth in those. But my first question would be, what is, in your opinion, why is Kubernetes a good platform for ML? Or is it? Or, right, do you need, what kind of extra support? I don't know, it's a lot of things, but why is it a good platform for ML?
It gives you a lot of power, and also related to the elasticity that we were talking about, right? It gives you a lot of power, it gives you a lot of flexibility, and the isolation is also there, of course, right? Because in the end of the day, it's a container orchestration platform. I think the combination of these three makes it quite powerful for two things, not only for productionization, but also for something that we all need, which is reproducibility, right? One thing is, I am a data scientist in one team. I create my own Docker image to package a model. I've seen places that they were quite happy with running these in a Docker engine running in a virtual machine. But then you're pretty much limited to the kind of stack that you have running in the machine. Whereas if we transpose that to the Kubernetes world, you can simply say, okay, I want to allocate 16 gigabytes because this other guy was using the same amount of memory, 4 CPUs, and so on. So I think this power and this flexibility allows you to reproduce most kind of experiments by controlling type of factors. So I think, in my perspective, it would be a combination of these three.
That's good. I like one follow-up then. So to continue with that then, and this is something that I've continually trying to form an opinion on myself, but it's obviously, I agree with you. Kubernetes is a great platform for ML, but is it always the right answer? And what does the team composition or what does the organization look like where it's the right answer?
I think we were in an area where nothing is really exact science, right? Despite the classical conventions. I think I'm going to give two examples. I've worked in companies with these two types of landscapes, right? So you have one company where teams are isolated. Each of these teams are doing their own thing. And in your team particularly, no one knows about Kubernetes. No one knows what it is. No one is able to support it. And I was crazy enough to spin up a Kubernetes cluster in this type of setting. That was a huge experience. But your mileage may vary, right? You need to be willing to support this, that old saying, right? You build it, you own it. Or you need to get the buy-in from people, right? Some kind of commitment in a way that someone will support that stack at some point. And it's not easy to find people who know it. So I think just to wrap up this first part, if you don't have enough maturity, and at the same time, if you don't require that level of scale, you might be pretty okay with running Docker in a virtual machine or a couple of virtual machines. And that's pretty much it, right? On the other hand, if you have a mature organization, if you need the scale, but at the same time that you're going to be able to get the right amount of investment and the right amount of enablement, then I would say go for it. So if you are okay with the idea of supporting it, because let's be honest, it's also a complex beast to support it. I think for deploying stuff, it's amazing. Now, when it comes to supporting it for mission critical applications, 24/7 stuff, yeah, you need to be aware of what's part of the game. If you are aware of what's needed and you're fine with that, you're not having any problems sleeping at night, then I would say go for it.
How many times have we heard that story of just the lone data scientist that now needs to figure out Kubernetes because they can't get DevOps resources, or DevOps is too busy to give them the time of day, and they want to show some business value with all of these Jupyter notebooks that they've got. And so they're trying to figure out a way to do that. And next thing, they learn Kubernetes, and it's 6 months later or 7 months later, and they start getting into these networking issues, or they start banging their head against the wall because it is a beast. And as one past guest, Brandon, said, he was like, yeah, Kubernetes is a beast, but I'm so happy for it to be this beast because it allows you. Yeah, exactly. It is so crazy to just sink your teeth into it, but I need that kind of that horsepower. I need the oven to bake that hot for me to be able to do what I want to do.
Yeah, exactly. And I think it's amazing when that happens. When I hear these kind of stories, unfortunately, I don't hear a lot. But when I see those things happening, data scientists rolling up the sleeves and learning Kubernetes, I think to myself, hats off to this guy, man. And the framework itself has evolved a lot over the years, so now these kind of things are possible. But I think there's still a lot to overcome. I think, let's be honest, I'm curious for the experience you guys have as well, from the conversations you have, but also from your experience at work. But in my experience, not a lot of people are willing to invest the time to learn it. And you even have some tools which promise to make this transition smoother. For example, the other day I was given a Zen ML spin and was quite amazed by it, to be honest. So I think one of the biggest purposes for it is to remove this friction, let's say, right? From the modeling and the experimentation part to the exploitation part, kind of encapsulate this overhead, all these things you need to know, but you still have some other responsibility.
Yeah, I think the best story of this that I've heard is, and it still is hands down my favorite introduction in the MLOps community Slack. This guy, Ale Solano, came in and he said, I was a happy data scientist until my boss told me I need to deploy the machine learning model that I created. And now I'm in here. I find myself in this MLOps community. We actually interviewed him probably like 6 months back. He's like, yeah, I'm not really even a data scientist anymore. I'm so into this whole engineering thing. I hung up my Jupyter notebooks and now I'm just getting into the raw code. And so it's cool to see that is possible. I do agree with you. That's a little more few and far between. And I know a lot of data scientists who are happy just saying, here's my Jupyter notebook, do whatever you want with it. I just want to know if my accuracy score is what I think it is when I was training it, and like everything else you take care of. That is probably the cultural side of MLOps that we need to talk about more, and we need to have people understand. I really like how Ewan Nicholson talked about it when he came on the MLOps community meetup one time, the virtual meetup, and he mentioned how there is a difference now that he sees with basically because of the MLOps movement. People start to understand, like a data scientist, a data engineer, an ML engineer, an SRE, they all speak the same language, and there's not clear borders of where one stops and the other starts. It's almost like this, if you were looking at a picture frame, and in the first picture on the left, you have all of these colors that it's just like yellow, blue, black, white, and it's very clear where one color stops and the other color starts. Now, what his way of seeing it is like, now it's almost like a gradient where you're not really sure which one starts and which one stops where. And that is an incredible viewpoint. And I think that's like what we try to aspire for. And you're probably in a healthy organization if that's how you're doing things, right? If everyone can take a little bit of weight off of the other person, or their job function doesn't necessarily sit right in this one spot, and then everything else is not my problem.
Yeah, exactly. No, I think you hit the nail on the head there. It's interesting, right? Because we start to connect to a bit more, let's say, philosophical aspects, right? So the company culture, I think, that plays a huge part as well. If people are stimulated to try new things, if people are stimulated to help each other, to step outside of their comfort zone, then that kind of situation described is naturally going to happen. But you also have places where usually people are not stimulated, or they're not stimulated to get outside of their comfort zone, or they're not stimulated to help each other or to try new things. Sometimes they're even penalized for trying new things. So in this kind of setting, it's natural that each person is going to protect their own turf. I do my data science. I don't want to. I run my models. I create my models, train my models. I don't want to be the one who's going to be called up at night if things stop working. So my work stops. Here is your Jupyter notebook. Now it's your job to bring the model from Jupyter back to Earth.
I'm just going to echo like a lot of these things, my experience, right? Like, one, you're right. I really, maybe it's because I'm like this person, but I really enjoy the idea of that, breaking those barriers, because that's where I think, like you said, the company, like a culture that has that, where everybody's understands to some degree, right? It's going to vary, but they understand what is required to take their idea to production, let's call it. So I think that is critical. And I got to say, the data scientist that rolls up their sleeves and starts to get their hands dirty a bit in the software side, on the engineering side of things, I think that's healthy, especially if you're going to be working with SREs, machine learning engineers. Yeah. It's important that everyone tries to speak that same language. Like, yes, that's just, I've seen that's where the most success is as well. But that's awesome.
No, it's exactly that, right? And I can also imagine, I think it's definitely a win-win situation, because, for example, let's say that I'm a machine learning engineer. And in the beginning, we have this way of working where each person sits in their own silo. Data scientists, they just train models and they bring to us, and machine learning engineers say, hey, here it is, you deploy it. So this is one thing. Another thing which is completely different is the same data scientists coming to you and saying, hey, can we do a code review together? Can you give me some pointers on how to make this better? Can you show me how you do your work? Why I say this is a win-win situation, because for the data scientists, it's a learning opportunity. And for me, as a machine learning engineer, to see that kind of interest, that's the definition of teamwork, right? You're not just coming and say, hey, do this for me. It's not a production line kind of thing. It's actual collaboration. So I think, the chances of effectiveness in this case are much bigger. And I think this doesn't apply only for machine learning engineering and data science in general, right? I think it applies almost for everything.
So I think, I totally agree with that. At least, anyway, that skill applies for a lot. I want to dig in a little bit now because I think we've talked a little bit about Kubernetes, right? And talked about it, but we know you also work for Databricks. So I had this question. This is my first question I actually wrote down before this. This is I wanted to ask you. So when does it make sense? This is still kind of the same theme, right? But when does it make sense to use a tool like Databricks over some open source software on Kubernetes? Like where is that? It kind of goes back to my original question. Like, what is the type of team dynamic? So where does Databricks come in and help? And how has it changed? It's been like a year and a half since I've really dug in deep to Databricks as a single platform. So I'm sure there's been a lot that's changed since then. But I'm curious to know from where does it make sense? Like when does it make sense to use a tool like Databricks over just going full open source in case?
Yeah, no, that's also a good question. It's interesting to think about this because I've lived both worlds, right? I was running Kubernetes clusters before to deploy machine learning, and now with Databricks we have Model Serving version 2.0, which is basically serverless real-time endpoints. And we deploy that. Sorry, there's someone ringing here. We're deploying that. So it's basically the idea of platform as a service. Some people call it platform as a service or software as a service. So I think in a way the same kind of advantages apply, right? Sometimes, for example, what makes you go with deploying your own Apache Kafka cluster instead of running on Confluent, for example? A bit of the answer is quite similar, right? If you don't want to manage it, if you don't have people who are skilled in that technology, and you don't want to have that kind of overhead, I would say that it definitely makes sense. But I think in the case of Databricks, there is one important addition, right? I think for a long time, our vision has been to be our go-to platform for doing all things machine learning. So I think one of the northern stars is that the less platforms you need to manage, the more you can focus on your data and on your extracting business value out of the data, right? So I think this choice in this case is pretty much in line with that, right? I think if you see the value in shifting this effort from managing these platforms to running this as a service so that you can focus on other things, I would say that's the biggest difference in this case, the biggest advantage.
Okay, so here's like the point blank question now. I come to you and I say, all right, well, I have a Spark operator on my Kubernetes cluster. Why do I need Databricks? What does it give me? What else do I gain there?
Yeah, good one as well. So I think, again, part of the answer is the same. You won't have the overhead that you have. I don't know how much overhead you have, actually. It depends your mileage for RISE. But I've seen companies that have 50 people to manage a Spark cluster running on Kubernetes, other companies, 10 people, and other companies with one person. But I think the fact is you eliminate that overhead. That is a fact, right? And on top of that, I think from a functionality perspective, you have other bonuses, for example, photon acceleration, which is something that is part of the offering that we have on Databricks currently. It's not part of the open source version. But I think the third and the biggest one is still related to the idea of centralization, right? So you don't need to move between different silos, different platforms, because everything is running inside the same box. So that unlocks a lot of benefits when all your data is in the same place, but also most of your underlying infrastructure is in the same place. You have less things to worry and less. So I would say that's the biggest advantage.
It's funny that probably 6 weeks ago, I was in New York and I met up with Cheeto, who also has been on here in the podcast. And we were joking that Spark engineers in big companies, they can do absolutely nothing, but they are so vital to those companies that they're like hiding in plain sight. You could sit back, get this huge paycheck, and really be like the linchpin for that whole company because of the value that Spark has and what you were talking about, like that overhead and potential, like basically business is running on top of this, like all of these use cases that are running on top of it. And if Spark fails, you are SOL. But I wanted to shift gears a little bit and jump into something that you were talking about when it comes to the best way to structure and promote code across experimentation and exploitation environments? Because I feel that's something that we see a lot of, especially I think about the Google paper or the Google like best practices of MLOps, where they talk about here's the level 0, here's level 1, here's level 2. And as soon as you get to level 1, there's like that separation between the two environments. And have you seen or have you tried to recognize some patterns or some ways that work best when it comes to promoting the code between those two environments?
Yeah, that's a really interesting question. You were saying about this paper from Google. I think recently Microsoft also published something, and instead of 3, they talk about 5 levels of maturity.
Yeah, totally.
I don't remember exactly what are they, but I think people's companies and people's ways of seeing this are changing quite fast. I think there's no silver bullet. It will pretty much depend on the kind of, I always like to think about the kind of problem that you're trying to solve. You can deploy code across different environments, but you also have some companies who just train a model in experimentation and just promote that model to production. They are fine with that. So I think just to illustrate the difficulty in saying what is the best way. Just to try to make this more concrete, if you are operating in a tightly regulated environment, really critical, you cannot afford for things to stop working. Let's say, for example, you're running fraud detection model. If the model stops for 10 minutes, it means that you lose millions in revenue. That will dictate, in my perspective, the amount of complexity, let's say, or of features that you have when it comes to these pipelines to promote these models from exploration to exploitation, right? So things, for example, unit testing, integration testing, A/B testing, which is something not all companies do. And then some companies, they also go an extra mile and do some things which are even more sophisticated, like Thompson sampling, for example. They want to really make sure that they're extracting the biggest performance as possible. And for that, they want to battle test all these model versions. So I think your particular needs and your scenario are going to dictate that. Yes, that's the way I like to approach things, not only in terms of this problem, but also I think machine learning problems in general.
And when you think about these trade-offs that are like the flexibility versus simplicity, or the impact versus complexity versus ease of use, all of those trade-offs that you're juggling in your head when you're looking at a platform and putting together something that is end to end, how do you rationalize each one of those questions? And let's take it, because I know it totally is specific to each use case. So if we were going with that fraud use case, let's like take that as our example, because I think that is a fairly common use case that a lot of people are dealing with, and it is very mission critical.
Yeah, for this case, for instance, if I were in charge of putting some system like that up, I would want to be as restrictive as possible. So only pull requests to merge code to create a new release, reviews from at least 2 people to merge these pull requests and so on. And I think, actually, if you think about it, in this kind of, when you reach that kind of restrictiveness, or to keep it in a positive term, that level of maturity, it starts to look a lot like a mature software development process, right? You have pull reviews, you have code reviews, you have 4i principle. In this case, I want to be more as restricted as possible. And the reason for that is that the stakes are really high. I don't want to be the guy in charge if something stops working. The impact can be huge. So in this case, this is the approach that I would try to do. But you also have other things that you need to have in mind. You're not able to reach this level of maturity if you don't have the right resources, if you don't have the right team and the right knowledge. It's also not something that happens overnight. I think it's more of a change in mindset than something tactical for the short term.
I like that you're talking about how it resembles a mature software architecture or a mature software organization. Where do you think it doesn't resemble that? Like, what parts are different?
I think the way I see it on a high level perspective, so with software, you only have one type of artifact, which is the code itself, right? Machine learning, you have the code artifacts. So in this case, there is an overlap with software development and software engineering. But you don't have only one artifact. You have three types of artifacts. You also have the models, and you also have the data, of course. So you need to manage and to have a process that is comprehensive enough to cover all of the three. And each of the three are different disciplines, if you think about it, right? For the models, you are worried if the model is going to be performatic enough, if the metrics are good, if latency is low enough, depending on the use case, right? For the data, you are concerned with data quality, with PII, how you manage PII data, for instance. Yeah, there are more nuances than when you look into software engineering. Not saying that software engineering is easy or anything like that. It's just that there are more disciplines involved.
When you're talking about, you're absolutely, I agree with you 100%. There's more artifacts to deal with when you're talking about ML. So in your opinion, what has been the best way to deal with those artifacts? Like obviously with code is probably you're using your repo. When it comes to a model, what are you doing with that model? How do you treat that model? How does version control work with that model? These are questions that I'm constantly asking myself all the time. What's the right answer there?
Yeah, that's a big challenge, actually. I think if you ask 10 different teams, they're going to give you a different answer, right? But I think this is also where having a centralized platform has a huge impact, right? Because, for example, if you are training your models and serving your models and tracking your experiments and runs in the same place, and your feature stories in the same place, then you could simply open up your model registry, and then for each of your models, for instance, you could see not only the metadata associated with the model, but also what kind of features were used to train that model. And that is huge. If you have, on top of that, if you know what version of that data was used to train that model, let's say that 1 week from now, your data is not the same, but you still want to take a look into that type of data that was used to train your model. Because things nowadays change pretty fast. People leave companies, people join companies. To have that kind of traceability and that kind of a track record is a game changer. So I would say, again, I want to repeat myself in saying, yeah, there's also very well. But for instance, if you want to have the full feature set when it comes to the visibility of these artifacts, I would like, for example, to have information, to have the metadata about the data that I used to train the model, about the metrics and hyperparameter. I think having these tracked, it's almost like a commodity these days, right? I think it's the basics to have some kind of visibility. But also, you will want to know who trained this model, who changed this model, which is even more important, right? And last but not least, also to have some safeguards to specify who can approve a model promotion from staging to production, for instance. When was model X promoted from development to staging, and when was it promoted from staging to production, for instance? To have all these treasure trove of data, I wouldn't say today that is a luxury. I would say more and more this is becoming quite essential, not only to keep the stability of machine learning systems, but also for ability, for instance, you need to know what data was used to train your model to provide explainability, to provide fairness, and so on.
Yeah, and actually, one thing that's funny, and Ryan, maybe you have some thoughts on this too, is I know that I've talked to, and when the company that I was working for in 2019 that was doing MLOps, we were hearing a lot of people talking about RBAC and how necessary RBAC was for what they needed to do. And I'm wondering, I feel like that is still top of mind, especially when you get to larger organizations. Do you all think about that as something that is a must-have, or?
It's a must-have. Role-based access control is extremely important, right? Like you've got to ensure that just based on what is your role in the cluster, what is it that you do, what is your role in the team, it all matters. And how that's handled today, and probably it's definitely evolved. There's definitely more tools with the cloud vendors and such that provide ways to connect that up to your cluster and make it easier to use the IAM and whatnot. But yeah, it's absolutely like a necessity, I would say. I don't think it's something you can get away from. Obviously, it comes with its own headaches. And so if networking is the hardest thing for me at Kubernetes, that is the next part, is the security side. I just feel like a complete noob at all the time.
100%. And I completely agree. I think 100% RBAC is also one of the things that's becoming now, it's shifting from a luxury to from an extra feature to something that is essential, right? Because the impacts there are multiple impacts if you don't have. It doesn't necessarily mean that that you cannot run ML without it. You can, but you need to be aware of the consequences. And I think I would add one other aspect, because I think a lot of times in the data community, we talk about data lineage, but we don't talk a lot about model lineage, at least not in the circles that I'm part of, which is equally important, right? For example, if you can watch the life cycle of a model, almost like it was a child. When it's born, it doesn't know how to read. It starts walking, it starts talking in really simple terms, and then it becomes this really smart adult. What kind of school this person, or this model in this case, what kind of courses or classes they've been to, that can be quite useful, right? Who were the people who taught this model all the tips and tricks, all the right stuff, but also all the wrong stuff? If you're able to pinpoint all of these, that can be quite powerful. And again, I'm also really sure that pretty soon this will be mandatory. This will not be an option.
So for model lineage, is this like an obligatory plug for MLflow or something at this point, or what? Sorry, side comment there. But what are your favorite tools for model lineage? I'll add that.
He gave you a softball.
I gave you a softball. Here you go.
Let me think about it. No, I think MLflow, I'm not going to lie. I mean, I'm completely honest. I think in terms of maturity is one of the most mature tools out there. But the moment that we are in this industry is so unique, because you have so many people doing really nice things in this arena. And I'm not even talking only about model lineage or experiment tracking. There you have weights and biases, which is an awesome tool. Comment, which I never use, but they seem to be doing some nice stuff. So it's quite exciting. All of these tools, they have their main applications, right? I think where MLflow definitely excels is one, in the maturity, and two, it is quite comprehensive as well. So you can basically track and register almost all types of models out of the box. And then you're talking about something like, okay, you write one line of code, enable auto logging, and bam, that's it. You're logging everything you need. So this is quite powerful.
Yeah, that's killer. Yeah, shout out to Corey and Ben, who are on that team, working hard on the MLflow, the whole project there. Now, Rafa, man, this has been awesome. I thank you so much for coming on here. We're going to have to wrap now. Everyone that wants to learn more about Rafa, I highly encourage you to check out his website. It's MLOps How To. Rafa writes a lot of thought pieces and a lot of tutorials and a lot of just great stuff in that blog. So check it out. We'll leave a link to it in the description. And if you enjoyed this podcast, you know, it would be awesome. Tell your friend, share this with one person on the internet, and we will happily thank you for doing that. So that's it. Thanks, y'all.
Thanks.
Cheers.